just going to quickly run through the ARIS installation on the Deveron, highlighting progress that we've made over the first year, some practical considerations, and a few of our initial results. You'll note I've highlighted under camera there. In its own right, it is not a counter. As simple as it is a sonar camera, and then all the counting is done after, as I will explain. So a little overview I want to cover, a bit of background to the project, how it was installed, the setup, site selection, the counting process, some initial results, and then a few conclusions from the first year. Okay, so the background, it's delivered in a partnership with the Atlantic Salmon Trust and the Marine Directorate. The capital cost of the install, an initial 2-week trial, was covered by the Scottish Government through funding announced by the Cabinet Secretary in October 2021. And then I do the practical running of it with some support from the Atlantic Salmon Trust. So the fish setup that we've got, it was FishTech won the contract from the Scottish Government to supply and install. This is an ARIS 1800 unit with a rotator arm, which is this sort of U shape. This allows us to remotely from the riverbank adjust the angle of the view, as it were, on a vertical plane and horizontally as well, which is really quite important when you're making sure you're getting the right image to ensure good counting. And I would anybody who's looking at it highly recommend considering this extra cost. We have had a huge amount of interest since installing this on our experiences. So I'm hopefully going to sort of share what I've learned in the first year to help anybody else who's thinking of a similar setup. The 1800 has 2 frequencies. If you're working under 15 meters, you can work at this higher frequency, which will give you a higher definition and a higher accuracy. Our site is about 21 meters, so we're at the slightly lower frequency, but just reduces the precision of the images of them. It's currently on solar power, although we're having the mains put in today, fingers crossed, second attempt. Solar power has been fine for the first year, to get an idea of how well it works. A little bit unreliable, even with high-tech lithium batteries, etc. We have had problems during the winter with power outages and problems. Lithium batteries, for anybody who's trying it, are brilliant, have a lot of benefits, but they are nowhere near as robust as lead acid when it comes to being in a damp environment. We had some fail, cost £500 each, set the back, and it was just the circuit board that just got damp. It's sitting in a container on the riverbank. So for anybody looking at long-term use of batteries, just be slightly wary of the chips and circuit boards inside these batteries. Our experience anyway, although I'm sure there's some specialists here on batteries. I see them pop up at the back. Our setup is currently on a temporary structure made out of scaffolding poles, weighted into the river. It is, as you can see, temporary, and we do remove that on any risk of flooding to make sure we take it out. It is carefully secured as well. We are working on a more permanent structure that will give it protection and provide a longer-term deployment. But we needed to make sure the site worked. The data we got was looking good before we invested in something more long-term. Site selection, I think, is key to the success of any project. There's a fair amount of background that went into choosing the site that we initially suggested FishTech try. Richie had previously tried cameras at various points in the Deveron. We'd tried ARIS at a few other locations. We had spent quite a bit of time getting the help from NRW. Richard is giving a talk after this, and he has been invaluable in helping us with all aspects of the project, but particularly in sort of some suggestions and site selection. Every site is different, and that comes to the physical nature of the site, but also in how the image that you get of the processing and how it will look when it actually comes to working. Distance from the sea is obviously key, depending what you're looking for. We're looking for trying to get a whole river count, and so it's just a couple of miles up from the tidal limit is about here. So it's 3.5 kilometers up above that. First decent site we've had really to try. Access is obviously important. It requires being checked on, certainly initially, and weed and debris and flood conditions and power. Power supply, as I've said, battery was good initially, but moving to the mains is quite important in the long term. Considering fish behavior at your site too. So previous video deployments had shown a site we tried before was very problematic because the fish just came up and down and up and down and up and down. So that was going to massively increase your processing time, probably reduce your accuracy. And then considering your depth and cross section, it is a camera with a beam. It's got a the basic unit has a 14-degree vertical sort of splay on the beam, and it's 27 on the horizontal axis. So you need to consider, how much of your bed is that going to catch across, so the closer you're pushing. So this is our site. It's just upstream. Flow here is from left to right in this direction here. It's just above this historical croy, which means the water is actually flowing through here quite quickly. And the idea was that the fish will be pushing up through here, and it'll just swim up through the beam and carry on, and hopefully not come back and go around the circle. This section down here is much slower water, but we were concerned that the fish there would. So that's our site. It's about 21 meters wide. So just moving on to some of the practical considerations in the counting process itself. It is a continually, well, the way we've got it set up, you can use the software to program it to run however you want. Sample for periods in an hour. You can make it program so the rotator arm will move and it points in different directions, different parts. We have ours just fixed in one position, and it is recording continually. So you have a video recording continually, and that produces a huge amount of data, which is then quite cumbersome to handle. We've had to invest in, with the Atlantic Salmon Trust's help, this significant piece of equipment, which each of these slots is 12 terabytes, just to be able to store this data. So we have a small hard drive in the container with a laptop that is storing this data, and then every week or so I'll go and swap that out and change it over and put a new one in and then transfer it onto here. But you're talking about when you click it for transfer, even directly plugged in, it's like 8 hours to do it. So it's just real practical considerations of how you handle that. Backing it up to a cloud, even with hardwired fiber, is pretty time consuming and expensive. So things to consider. This is the screen I now spend too much of my life looking at. This is the software that you run you process the footage that is recorded through. We have it set up to record in half-hour slots. So imagine this is a bit like a film strip of half an hour of footage along the top. So this is called your echogram. And then this is one snapshot of that. So you're looking at this section at a time. You see something like this. This is a fish, or it could be a bit of debris or whatever. So whatever you want to check, I basically go through it manually at this stage. There are some tools that can speed that up. But at this stage, I click through this, through the half-hour echogram manually. I'll stop and look at this section, each section, have a look if I see anything that looks like a fish. And then you use the mouse, you draw a little box around it, and then it plays back that bit of video in this sort of aerial view, as it were, of your cross section across the river. And then you get to see your fish, or whatever it is, or bird or otter, swim through, and then you can decide what you have to do with that. If it's a fish, you stop it at a good section where you can see a nice image of the fish, you draw a line along it, that's your length measurement. You then click save, and it creates a line in a spreadsheet. So you're generating one Excel spreadsheet for every half hour, and then a line within that for anything you record. So this is a large salmon going through to get an idea of the kind of image you're getting through. Just over 12 meters there, you can see it. So this fish, I think it's about 90 centimeters going up through. Typically, most of our fish in low conditions go through this section here, because the croy downstream, the sort of deepest gap is about here in this section. So I would pause that when I get a nice image. I'll watch it go through. I might watch it a couple of times, pause it, and then I find a gap where you get a nice image, and you can then draw your line to measure it. Obviously, fish that get really close, you get a sort of sharper image. Sometimes they're too close and you struggle to see them all. But the majority of the fish for us are here. You do have to watch carefully. Fish going over the sort of gravel bank on the far bank are a little bit less visible. So you have to watch carefully on the echogram to make sure you're picking them up. The behavior of salmon swimming upstream is pretty clear. You get pretty good at that after a year. Rich from Wales has been helping me with identifying eels and lamprey, how they look different. Otters are very clear because they leave a big air trail from all the air that's entrained in the coat, so they leave a kind of stream behind them. Goosanders, we've had hunting goosanders, they look kind of like fighter jets because again they leave a trail of sort of vapor behind them, it looks like. So learning quite a lot about different behaviors. We saw the smolt going down, so you had a rough idea. We can count them, but you had an idea of what the smolt run was at this position of the river. So some interesting stuff there. So that was a nice image with one fish going through. And in July, when we had quite significant numbers going up every night, it was, very different. This is 4 or 5 fish that were coming downstream, sort of backsliding together, and then immediately turning around and coming upstream. You can't disregard any of it. You've got to process it all and put it down as a downfish and then an upfish or a milling. That's going to be real important how you try and turn this data into a count. So this rapidly becomes far more time consuming. So the counting process, as I've said, is very dependent on the fish behavior. So for the months of the year, this is a quick summary of the different behaviors that I've recorded. And you really want to make sure you've got a good proportion of up fish and you're not having too many going milling or going down, because that your time then is just going to massively change. So there are some options. There's built-in software in that program that could allow you to chop that video footage down to fish events. Basically, it takes the sort of background noise and then you can set thresholds and it'll chop it with a buffer down to those fish events. I haven't been confident to use that yet, because I want to make sure I'm looking at the raw information and sort of understanding what they're. Rich in Wales, who's going to talk soon, has developed their own NRW system, which I think is a more refined version of that. And hopefully we can move on to AI and sort of machine learning on this information. Other places I believe have. I think it will be quite site specific. You'll need to teach the machine your site because of the level of noise in the background, but that's not my area of specialist, but hopefully we'll get there. There's then a sort of bit of a practical consideration of you're generating 40 Excel files a day, and then you have to try and sort of get them all into one file. And then I'm currently dealing with an Excel sheet that has 12,000 rows in it, which is a little unstable and outside of my comfort zone. And probably for analysis things, I should be moving on to R, but at this stage, I'm just stuck behind how to do it Excel. So steep learning curve, but we're getting there. Results. So I've so far processed from the 24th of February to the 25th of September. And this is just an initial sort of stab at looking at those results. It's unverified. And quite a steep learning curve, but just to give you an idea of what we've got so far to show what the potential is. So quickly, the length frequency distribution. This is just the frequency of length of all fish that I've currently recorded, counted, going through. It is a little bit skewed because to start with, I was recording everything down to sort of 15 centimeters. But when you've got trout sitting there milling around at that size, very time consuming. So more recently, I pretty much don't look at anything below 30 centimeters. That's a counted report. So there is more down here. It's just not that clear. So obviously we've got a bimodal distribution, which is our trout and our salmon. Obviously this area of overlap is key, and how much overlap there is between smaller salmon and larger sea trout, brown trout. We haven't tried to quantify that yet. And then within that, we could begin to look at, what's our distribution of, our abundance of grilled versus salmon, if we were to sort of use a similar to what Stuart was talking about, anything 65 and above, maybe being salmon. But it needs a bit more work on that. That's just a rough idea. And for the graphs and numbers I'm going to show from now on, I've taken everything of 55 and above. So I've disregarded anything below that. That means I am throwing out some salmon. I get that. And I'm probably including a few trout. But that's as simple as I can do it. But just now, just to give an idea of what we've got initially. So this is the whole time I've done. So we're starting at the 24th of February here, going right through to the 25th of September. The blue bars are what I recorded as an upfish. That's a swift fish that swims through from the downside to the upside and goes right the way through. If a fish then drops back down again, it's a downfish, and that comes off. And then the dotted line essentially is the kind of net count, the balance of that. So it gives us some idea of the run timing that we've had going through the Deveron this year. Slowly building up. This is kind of the middle of June, then sort of backs off for a while. This is probably when the hottest conditions. It might be to do with that, the fish may be moving less. Then into July, from memory, I think it sort of cooled down a bit, and the rain sort of cooled up a bit. And then slowly backing off. It's been pretty remarkable, actually, once we got the second half of August, which I think matches our experience on the river. We used to have a very strong grill run. The big years in the Deveron were all on back end grills. That is gone, and that is the big back of what we initially seen here. And you can see here, so once this is just river level using, it's not the best data I've got for river level at the moment. It's from the top of the catchment, but it's the best I could do it short term. So this blue line is just the amount of water in England coming into the top of the catchment. And then these are the bars, the same as the number of fish going upstream. So you can see once we get into July, and there probably is a head of fish in the bottom of the river. As soon as we got a rise of water, fish began to move. And then again, sort of the same towards the end of September, a few fish moving a bit of the road. So that's just a quick whistle-stop tour of our first year experiences. I would say it's been pretty positive. It's a lot of work, a lot of time, but it has produced some really encouraging results. I think the numbers that we're getting are looking very much in line with what we would have expected from the conservation limit and from the angling catch. It sort of fits within the sort of models and estimates that are being produced elsewhere, which is encouraging. And it's effective at the Deveron scale. Obviously, there's a completely different thing to consider if you're on a river with a far bigger run. The previous estimates of the conservation model, sort of around 5,000 in 22 and 23 was the estimated run. A bigger river, obviously, the number of fish you're having to count, it's just going to make it far more unwieldy to run. Definite challenges in terms of the amount of time it's taking, but also, weed on the structure in front of the camera and having to clear that off. Issues with power, but we're now moving to mains, so that should be, and then coming up with some sort of long-term deployment structure as well. But we're working on those. And then I think the next steps is really how we go about verifying this and how we go about quantifying the sources of error. So how many fish are we moving? At this point, we don't have a fish fence on the near bank where the camera is to push fish out in front of it. That's something we'll be doing. And how much overlap have we got there between salmon and sea trout and brown trout? How much might we be overestimating based on that? And then maybe trying to do a little bit of work on sizing accuracy. How is our sizing varying between the far bank and the close bank? And Rich in Wales have done quite a bit of work on that, but I think we might require us doing something we've got on site specifically. Thank you very much.